All the problems which we have seen up till now in statics, they were talking about only the two dimensions, but in reality the forces will not be applied in a particular plane. That means it is not going to be a two-dimensional problem every time. We have considered all the 2D features with respect to the assumption that they can be extended further for the real-time applications where the forces will be acting in the 3 dimensions, and they could be making some angles with horizontal, vertical, as well as there could be one more direction which could be treated as the depth. So now let us go ahead and apply these principles to a few problems which are related to the equilibrium in 3D. Also that we are required to find the moment of the force in 3D. So we will be now switching over to the problems where we will be given the coordinate system, which is a 3-dimensional coordinate system. So we might be having x-axis, y-axis, z-axis, and to specify the problem they might give us some 2 points, either in one form or another. We will be given 2 points in which the force is acting. So force AB bar is acting along line AB, and if coordinates of point A are x1, y1, z1, and that of point B are x2, y2, z2, this is origin, and magnitude of force is say F, then force AB is to be found out. Now as we have seen in 2D that the force is going to have the magnitude as well as the direction. Now if we are to write the direction in 3D, then it is not possible that we could be writing the direction as making some angle, because which angle we are going to specify. So here we will be writing it as the angle with x-axis, y-axis and z-axis, respectively known as theta x, theta y and theta z, or we could be writing it as a vector. So let us see the vector approach for it. Vector AB bar is to be written. So that will specify the direction. Vector by itself comprises of magnitude as well as direction. Let us revise a few features of vectors. Some vector P bar, which is written as P1I plus P2Z plus P3K, where I, Z and K are unit vectors along x, y and z axis respectively. Now when we say that it is a unit vector means magnitude is 1. So we can simply show the system in this manner. So this will be unit vector along x-axis, will be unit vector along y-axis, and this will be unit vector along z-axis. Now any point that we talk of in 3D, any point, the coordinates that we talk of, suppose this is point x, y, z, say point P, and if we write the vector OP bar, then remember that these coordinates are nothing but the distances. So this is the distance travelled along x-axis, distance travelled along y-axis, this is our y-axis, and distance travelled along z-axis. So ultimately this is the direction in which the movement will take place, and to indicate that it is direction x-axis, we will write it as xi plus yz plus zk. That is what we call it as the